Hello everyone and welcome to Mathematics. So today we'll dive into differentiation, and here's everything you need to know on limits. Alright, so let's start off with an example of limits. Okay, so how do we understand this? So LIM here represents limits. This arrow represents approach or near. So overall, to understand this is when x approaches to 1, f of x approaches to 2. Right, so if we use graph as example, right, let's say we have a straight line here and x equals to 1 is here. So when x approaches to 1 here means if I slowly approach to 1 from the left and let's say from the right, so both ways now, I will approach f of x to a value where it is 2, if according to this example lah. Okay, so if I slowly approach where x equals to 1, I will eventually find that my f of x is 2. Okay, that's the meaning behind. But you may argue, why we need to learn this then? Because this one is technically x equals to 1, f of x equals to 2. Right, straightforward, don't have to use LIM, limits. But there's another special case, okay? Sometimes we need to find the approximate value in functions. So technically for this case is the continuous case, or I would say the safe case, because we can find the exact value. We don't need to find the approximate value, because if you see here x equals to 1, there is a value. But sometimes we may meet cases where it is discontinuous. For example, like this. You can see that where x equals to 1, there is this blank dot here, which means where x equals to 1, f of x is undefined. There's no answer. So what we need to do is to find the approximate value. So how to find the approximate value? We approach from both ways first, find the f of x value which is close to this blank dot. Let's say 1.9 and 2.1. But eventually, if we move closer and closer, they will reach to a value which is 2. Okay, but take note, 2 is not the exact answer. 2 is just the approximate value, because the real value is where x equals to 1, it is undefined. Okay, undefined. So sometimes we need to use limits, because we need to find the approximate value. We cannot find the exact value. Okay, so now next question, how do we solve this kind of limits questions, which is quite popular in SPM, right? So the first and I would say the most straightforward way is to use substitution method. Very easy. The approx value I just sub into this function, and my answer is just 1 over 2. Very straightforward. But unfortunately, sometimes in SPM they wouldn't give you this kind of question lah. Sometimes it will be a bit complex, and most of the time cannot solve based on substitution. Okay, if you look at these two examples, right, if you substitute the value 4 into here and 0 into here, the denominators lah, you will find out that the denominator is 0. Technically it means undefined, but using a different way, we might find an answer for it. Okay, so this is why we need to use like factorize, rationalize, divide, these kind of methods, okay, instead of substitution. So for this one, factorize means we just need to find those quadratic equations, for example this one, and then we split them using calculator lah. So this one, x squared minus 16, I can split it into this way. Right? Reason is because I can cross off the things which is the same in the numerator and the denominator, and then I can only substitute the value here, the 4, to here. So here will become 4 plus 4, 8, which is my answer. Right? So for rationalize, the main aim is to remove the square roots. Right? As you can see here, there's a square root here. So how do we remove the square root? Is to multiply the conjugate. Okay, conjugate here means the value that has the square root, and we just need to find the opposite of it. So the opposite of it means if here is negative, we should multiply the positive one. If let's say this is positive, we should multiply the negative one. Okay, but this multiply, we need to multiply in the numerator and the denominator, both sides. Okay, so if you try it by your own, when you cross multiply, the square root will eventually disappear from the denominator. There will be a square root in the numerator, but the denominator will disappear. And that is where we can substitute 0 inside this function. Okay, so this is what we know as rationalize. And lastly, the last method is divide. So this one, technically, if you sub infinity inside, the denominator will not become 0, but here there's an x. So if I substitute x with infinity for both sides, it's actually infinity divided by infinity, which technically I don't know what is the answer. Okay, so to find a numeric answer, what we can do is for these four values, we divide the same unknown x. Okay, reason is because this x I can cross off. These two values I can substitute infinity inside. So this is like 2 over 1,0,0,0,0,0,0,0, a very large value, and eventually these two values are actually 0. Okay, so now you can see that everything here only left with numbers. This one is 5, this one is 5, and the others is 0. So technically it's 5 plus 0 over 0 plus 5. So it's actually 1. And that is your answer. Alright, so this is everything you need to know on limits. So if you'd like to view some walkthrough videos on limits questions, okay, feel free to click the links in the video description. And thank you so much for watching, take care, and I'll see y'all in those videos. Okay, bye bye.